So, ladies and gentlemen, I'm very happy to welcome you to another CIMAC Tech-Talk event. Unfortunately, on short notice, our host, Dirk Bergmann, wasn't able to join due to technical problems, which is really a pity, but I guess also Daniel, Dorte, and I will be able to manage that and to have an interesting discussion. First of all, the three of us, later on also with the participants. I take the chance to say something regarding that format, Tech Talks, which is rather new for our CIMAC community. We established that, of course, due to the COVID-19 pandemic, just a few months ago, after some webinars we have had already in 2020, we drafted that format as a virtual panel discussion rather successfully, I would say, with 2 events so far and a few further upcoming, and it shall be a format which is repeated not necessarily on a regular basis, but from time to time, whenever we have interesting topics to share with our members or also broader public on interesting topics such as today's one. And you will get the information on our Tech Talks always via the CIMAC website, but also via our Twitter and LinkedIn channel. So I hope you are following us already. If not, I'm inviting you to do so in order to be informed about our current activities. Now, as I said, for the today's Tech Talk, unfortunately, the host wasn't able to join. Therefore, I take over the moderation of that panel discussion. I'm Peter Müller-Baum, CIMAC Secretary General, involved in that topic on marine fuels, or in principle on future propulsion systems and alternatives to the current propulsion systems since quite a few years. So I hope I will be able to host that meeting as well. With me later on, we have Dorte Kubel from MAN Energy Solutions in Copenhagen and Daniel Chatterjee from Rolls-Royce Power Systems in Friedrichshafen. Before we start with the discussion, we wanted to give you a brief overview about our activities so far. The majority, I hope, have that in mind, that CIMAC published one position paper in combination with a few white papers on the matter of future propulsion systems, in particular with regard to e-fuels or chemical energy carrier, to say it in a more neutral way. And since that, we are in the discussion within our community, of course, but also with authorities, any kind of legislatory bodies, and so on. And our feeling was that it's necessary from our end to publish a new position paper, which gives a little bit more an indication how the future may look like, of course, and this is the reason why we are talking about a look into the crystal ball. Of course, we don't know neither the future in 2030, but of course also not in 2040 or 50. But it was our impression that it's necessary to at least to give guidance which kind of propulsion systems are more probable than others due to several reasons. But we are going to try that with a position paper, again in combination with a few white papers dealing with the technical details within the next couple of months. And today we before we do so, we wanted to discuss that not only within our Greenhouse Gas Strategy Group, but also with you, with the participants, with our members, and every stakeholder who is interested in that discussion. If you know our publications on that topic, you are aware of the fact that we have shown in these papers that there are, of course, a lot of different options in principle, starting from pure hydrogen via ammonia up to hydrocarbon e-fuels with different advantages and disadvantages, which comes, of course, also with a price. There are, of course, other options like battery-driven propulsion systems or fuel cells, which play most probably a role for, in particular for coastal shipping, but most probably not that much for deep sea shipping. But all these topics we would like to discuss today. And having said that, I'm very happy now to welcome my two colleagues here at the virtual panel, Dorte Kubel, as I said, from MAN Energy Solutions in Copenhagen, and Daniel Chatterjee from Rolls-Royce Power Systems in Friedrichshafen. And Dorte and Daniel, if I may ask you to switch on your camera so that I'm sure that you are at least online, since Dirk is it not, as I said. Welcome, Dorte, and welcome, Daniel. Thank you very much for joining us. The idea of as I said, the idea of today's panel is to discuss very frankly, in a sense, what our impression of the today's situation is and what we may imagine for the future. The title is chosen by purpose. Yeah, in fact we are looking into a crystal ball, so we don't know the future. And in that regard, we can't give any clear signal. It will be that kind of fuel or this kind of propulsion systems. That's not the intention of our today's discussion. But while we are discussing the different options and also the different points of view, the participants may get an impression about the, let's say, limitation of the potential options. I guess it would be already an advantage for everybody if we are not talking about 20 kind of fuels, but just 3 or 4. Not saying that this is a result of our today's meeting, but that's the way we may discuss it today. And I would like to start with Dorte. Maybe, Dorte, you can say something about your point of view from an engine maker who is dealing in particular with a big two-stroke engines for deep sea shipping, which have, of course, another technical background also than the smaller ships, but also smaller engines, the four-stroke engines. So maybe you can give us a first impression. What's your point of view regarding that crystal ball topic?
Yes, thank you, Peter, and hello to everyone. And I shall try to be the first to look into the crystal ball. Could say in general, these variety of new fuels that we look into could maybe be grouped in 2 groups. There are the zero carbon fuels, ammonia, hydrogen, and then there are the net zero carbon containing fuels. And as a manufacturer or developer of two-stroke engines, we are looking into the complete range. We already have engines for a variety of fuels, including gas, methanol, and of course the usual hydrocarbons that we have known. And we are particularly looking into ammonia as our preferred option among the zero carbon fuels. And of course, there are different challenges for the different fuels, and they also come with different, you can say, pros and cons. And you can say the major challenges for some of the new fuels are the safety issues, which would need to be, you can say, be sorted out and regulated by IMO. And then there is, of course, the whole, you can say, price issue. But for the moment, you can say we are quite open, and watching what is going on, both policy-wise and technology-wise. I think I will start there or stop here and see.
Yeah, thank you so far, Dorte. We will go into the details regarding these different options later on. But first, I hand over to Daniel. Daniel, I guess your view is more on coastal shipping, also including batteries and fuel cell applications, but of course also the four-stroke engine. So if you give us a brief overview on your point of view, I would be grateful.
Yeah, thank you, Peter, and also hello from my side. I think as from the Rolls-Royce point of view, we have maybe two extremes. So on the one hand side, really, we have even aviation, which has fuel as the only, or sustainable fuel as the only option. And if it comes now to our marine sector, which is mainly in the high-speed range, so coastal shipping and those, it's getting even more difficult to look into the crystal ball, because clearly we see there are new technologies. You can easily imagine for very short distance to have like batteries, and then for, let's say, point-to-point ferries, hydrogen we think is a viable option, because it's, if you think on e-fuels, it's the first fuel you can make, and if you have a point-to-point ferry, infrastructure is not that critical topic. But then there are also on coastal shippings, you have applications where you need higher distances, and so then you need the more higher energy density fuels. So where for our view, methanol becomes very interesting, and then you can even look on yachts, which may travel all around the world, and you need also like deep sea shipping global fuel availability, even in exotic areas. So that might be a small part of the complete maritime industry, that's clear, but clearly they need to operate. And then we are more on the drop-in fuel side, what would mean today they have diesel and then sustainable diesel. So our crystal ball is, I would say, we're working on all those topics and on the technologies, because easily if you talk on fuels, and I mentioned fuel cells, you can use methanol to have also different energy converter options. So you can use methanol or hydrogen not only in the engine, but also in the fuel cell. So that makes it even more complicated to look into the crystal ball. But I would say that that's the area where we need and to look into as an industry, and where we are looking at Rolls-Royce.
Thank you. Before we come back to the fuels, can you give our participants an idea for a typical application where battery-driven ships are reasonable, and where we will see fuel cells in future? From your, maybe from your personal perspective, where you think we have projects in that regard already, and that could be very interesting for future ships.
Yeah, so from my perspective, and then you see some of those projects, for example, if you have small passenger ferries for leisure purposes on rivers, and even on the Lake Constance here, that can work with a battery. Because to give you a simple example, if you take for example, one of our engine with 2 megawatts, and you would run it for 8 hours, so that would be your typical operation time you would use it, then you easily need 100 tons of batteries. So that's the main challenge. And if you have less power, you need less operating time, you can go for that. If you look for hydrogen, that again would be a point-to-point contact ferry. We see a lot of projects already in the direction Norway, so fjord ferries. That's like a small distance, and if you have a point-to-point harbor contact, you can manage the infrastructure. So I think that would be emerging projects for those type of fuels. But clearly, if it goes for longer distances and global operability of the ships, we need to go beyond the for sure batteries, but also the pure hydrogen solution.
Thank you, Daniel. And for to take an example for the Baltic Sea, for example, yeah, with shorter distances than, of course, from, I don't know, Europe to Asia, but nevertheless, it's not just 10 or 20 kilometers, that's quite a distance. Do you think fuel cells might be an option in the future, depending, of course, on the technical development of fuel cells, but in principle also from the matter of storing the hydrogen and so on? Would that be a reasonable option?
I would say fuel cells will find their way into the maritime propulsion as a part of the propulsion system. So, for example, to manage hotel load, things like that. And we believe also that we see for a lot of applications hybrid propulsion. So where we have always a combination of a main engine, which will stay, especially if you have high power demands, will stay engine. You have a battery, and you have maybe can add a fuel cell, and then you can play with that. So depending how battery technology is developing, how cost and power density of fuel cells is developing, you will just change the load and the size of those systems over time if you make kind of new systems. So as I would say, there's no completely a black or white, but also we don't believe for majority of the application that the fuel cell will be not on the short term the main propulsion system. So that will be always a part of the system, for example, hotel load, emission-free operation in harbors. But then even if you look on yachts or something like that, if you can go a longer distance, you will need a engine. And that, for example, that's why also in the industry, methanol becomes very interesting, because that's something you can burn in an engine, you can burn it in a fuel cell on cold burning, and basically you have then all the options, and you have some energy density. I mean, clearly diesel is hard to compete with, but it seems to be one compromise.
Okay, so considering methanol also as you said, as an liquid fuel for engines, what are the, and you mentioned some of the reasons why you are thinking about methanol. What are the disadvantages of methanol?
I mean, one disadvantage, it's still a low flash point fuel. So it requires some considerations, but the good thing is that there is already an IGF code, so it's not that new. It has not the energy density of diesel, and still today methanol is a global traded good. So there is kind of infrastructure, but there's not a bunkering infrastructure, and still methanol is mainly fossil. So just saying, okay, we go directly to methanol will give no CO2 effect. There is some biomethanol, and I think we see some projects. I think Maersk announced something where you can start with that, but this is clearly like the other fuels you mentioned, something, because at the end we need to have produced them all in a CO2 neutral way to get the benefit out of that, what needs to develop. But so handling is on one hand a challenge, but because there is already IGF code, things like that, I think that's on the way. And maybe you can referring to the hydrogen you mentioned, that it's in the preceding question, that's clearly completely open at the moment. So that needs to figure it out, and we learned how difficult this at the end is with LNG. If you think on some bunkering issues and requirements in different harbors, that's completely open and needs to be developed the safety issues and regulations for hydrogen, and that will take also its time.
Okay, thank you. Dorte, I come back to you now, and I would like to know also your opinion about methanol. But before we come back to methanol, I would be very interested in a few words, a few more details regarding ammonia as a fuel. Because ammonia have, of course, one big advantage, which is the missing carbon. Yeah, that comes also with disadvantages, of course, but first of all, and I will say something about that later on, ammonia don't have carbon inside that makes it most probably cheaper, and also for end of pipe regulation possible to use. Yeah, that's a challenge. We come back in the discussion later on also. But yeah, Dorte, your point of view regarding ammonia.
Yes, as I mentioned, ammonia is the fuel, you can say, we have in the spotlight of the zero carbon fuels. Ammonia is certainly not, you can say, an easy fuel, but our take was that it was easier than hydrogen, and that is especially due to the problems with storing the hydrogen. We could most certainly burn it, but it's especially the storage issue for the hydrogen. But ammonia is a new fuel, and we are in the process of developing both the engine, but also the supporting systems, possibly after treatment systems, and so on. So we expect that we will have an ammonia engine developed by 2024, and if somebody wants to buy it, hopefully you can say on the water in 2025. But again, that's a prerequisite that that somebody is actually willing to invest in such new technology. So that is, you can say, in the intense development phase. Methanol is more a known technology, a fuel that is more similar to what we know, and as Daniel says, the safety issues has been laid down by IMO in this interim guidelines. So there we are on safer ground, and yes, that is a possible future fuel, but again, of course, depending on production and infrastructure, which I guess we will also discuss later, but really are you can say, some of the uncertainties, because we can make engines for a lot of different fuels, but of course the infrastructure and the availability needs to be there, and the fuels need to be, you can say, sustainable and also, you can say, carbon neutral in a well-to-wake perspective for them to make sense as future solutions.
Yeah, thank you. In order not to ignore the white elephant in the room, we should talk also about the fact that ammonia is toxic. I mean, I personally would also prefer not to drink methanol or diesel, but nevertheless for ammonia it's a bigger challenge in a sense. But before coming back to that question, maybe I can just, because that was my part in the panel discussion, to say something about the production of these kind of fuels. Which is, of course, also a challenge. Yeah? So far, nowadays, we don't see any significant market for these kind of green synthetic fuels. Of course, we have a market for biofuels already, which is probably also increasing in the future, but nevertheless limited worldwide due to limited capacities. For e-fuels, is it zero carbon fuels or the mentioned net zero carbon fuels? We don't really have such a limitation. In principle, it should be possible to produce hydrogen in several places worldwide, not only for shipping, but also for other industry sectors. And then it's the question of how to how to further process those this hydrogen to other kind of synthetic fuels. Is it green ammonia or even the green hydrocarbon? Of course, this is not as easy as it seems now when I'm just talking about it. Yeah, of course, there are a lot of limitations, technical questions to consider, questions of sustainability, where to produce that hydrogen, how to store it, how to transport it, and so on and so on. But in principle, when we see how the hydrogen and Power-to-X industry develops just in the recent months, it seems possible to deal with these challenges. But then now I'm coming back on the matter of that fact that ammonia is toxic. When we solve all the other technical challenges, ship operators typically say, I don't want to use ammonia because it's toxic. I have a problem with my stuff on board the vessel. I need to bunker it, and so on and so on. So a lot of questions. What do you because from a technical perspective, you said it already. It's the ammonia fuel comes up with a lot of advantages. What would you answer to those ship operators questioning that ammonia is possible to be used on board a vessel?
Yeah, I can try. Yes, of course, it is an important thing to take into account, the toxicity of ammonia, and it is certainly an important part of our development project, which focus, you can say, on the engines and the systems surrounding the engines. But there we are going through all kinds of hazard and hazard analysis and building in all the necessary safety into the system. And that would of course need to go as well for bunkering systems. But what we do see is that ammonia is a widely traded commodity. There are ammonia tankers operating, so there is a lot of, you can say, experience both from shipping and also from land-based industry that we can stand upon and use as a basis for developing safety regulations and the necessary both equipment and procedures to ensure that the ammonia is operated safely. It is handled safely on land, on ammonia tankers, and so on. So we believe that it is possible to address, but it is also one of these issues that requires that there is a cooperation between the entire supply chain. It's not something we can solve as engine developers alone. We have to work with ship designers and ship operators and ports infrastructure. So it's you can say a challenge that requires industry to collaborate and find solutions together to ensure that it is, you can say, safe from a technical perspective, and that people also feel safe, and we do not end up a situation where ports saying we don't want ammonia ships or like that. But it's a big challenge that requires cooperation.
Yeah, but that is a good point. Yeah, it's also a matter of acceptance at the end, not only for ship operators but also for port authorities. So actually, if we don't have that acceptance at a worldwide level, it will become difficult to implement ammonia for a fuel for the shipping industry in principle. Good point, Dorte. Thank you. I come back to Daniel regarding methanol, but first I would like to give you the chance to add anything regarding ammonia if you want to, but then I would like to come back again on methanol as a one potential net zero carbon fuel, meaning it includes carbon, but at the end, if you have a closed circle regarding the production process, including direct air capture, we have a net zero carbon fuel. But yeah, once again, some additions regarding ammonia. Otherwise, feel free to figure out the problems regarding methanol as we have just done for ammonia.
Yeah, maybe only one addition to ammonia. So clearly, I think at the end we need also to be distinguished. So from our point of view, if you come to coastal shipping or with a lot of passengers on board, like for ferries, so that might be even a step further. But clearly it all depends. So that's I fully agree to what Dorte said. At the end, it's what kind of safety measures we find. And what are the standards if this safely can handle? So that will then change everything. And maybe one second comment. We usually start to think from the e-fuels from a perspective as a matter of trade global renewable electricity. And therefore, sure, ammonia, just to when you renewable electricity in Australia, you transform into hydrogen and you need to transport it because you might use it in Europe or somewhere else. And the cable from Australia, we probably will not get. And then I think ammonia is one of the most important carriers. And by that, there will be some market. There will be ammonia anyway. And then this really interesting question, okay, if somebody finds a good solution to handle this safely, I'm sure that will change the whole picture. And because then it is available, would be scalable, pricely interesting. And that's what we need to see. On the methanol side, I think that the clear benefit I see there and why I think at the moment it's so attractive. You can use from the technical perspective, you're somewhere in between LNG ship and a diesel ship. You can use the same tank. You need some coating. The tank shape can be very flexible, and so that makes it very attractive. And even you can start even with fossil methanol yet right now, it will bring you nothing regarding CO2, but what we see and others see, your emissions go down on IMO 3 levels. And then, especially if you look more on a local perspective, you can start with biomethanol, and then you get into the CO2 benefits. And I think that's one attractive thing with methanol. You can start a bit step by step into that, and then really, if for example, as operator, you go to methanol, and then at the end you can also use e-methanol. And that makes it very attractive. You get, even with the fossil one, some benefits, and you can, with biomethanol, you can step into that, which is not possible with the ammonia route. And I think that makes it attractive to start with something. And on the other hand, and that's also something where we look into coastal shipping, I don't think, and that might be true for deep shipping too, the one fits all solution. Because if you are more in a local environment, and we see that in Asia, there's a lot of interest still on biofuels because they have the possibility to get access to produce them. And in some other areas, and we see some projects in Denmark, that they go for methanol because they can produce it. And so that there will be different solutions. And therefore methanol will play a part of that. And especially in those deep sea shipping, in that coastal shipping, what I said already, we will see different fuels, I guess, in parallel. And what you said at the beginning, I don't think all fuels we can imagine, and we don't talk on fuels right now in this discussion like OME, DME. We believe that they will stay most probably very exotic, but the other ones, most probably they will find their way. And that's the challenge clearly for us as a propulsion or engine manufacturer industry to bring our customer solutions for that, because I mean it's always a challenge to have a broad portfolio and to keep that, and that's somehow the challenge, and that's why I think the next years, at least until 2005 or something, 2025, something like that, that will be where we need to have an intensive stakeholder dialogue with ship owners, with ship manufacturers, operators, to really find out and squeeze out what are the best solutions. And that's with that we get our crystal ball will become a bit clearer.
Yeah, I totally agree. I couldn't have said it better. I guess in 2025, maybe already a little bit earlier, we will have a complete different picture, because the current developments are really impressive. Is it the discussion about concrete projects? Is it the political discussion on at very high level, but also regarding the details for shipping, at IMO level, but also now we are talking in the European Union about the inclusion of shipping into the energy trade systems, which might be also a game changer for the European Union, or for the shipping within the European Union. But yeah, thank you both here for your comments so far. Daniel, you mentioned the OME and DME fuels. That's maybe something we need to explain to the participants, but I would like to take the chance first to invite everybody to ask questions via the chat. We are receiving already the first questions, but please, everybody feels free to enter your particular questions. We will try to answer that as well. Now we were talking about rather comprehensively on ammonia and methanol. There are of course other e-fuels, not only the high sophisticated e-fuels like OME or DME. We can talk also about simple diesel substitutes, which could be used also as a drop-in fuel. Maybe both of you can say something regarding those fuels from your point of view, but I would like to come up with a specific question for methanol, not for ammonia, but for methanol. As we said already, we need a technology of direct air capturing at the end to produce really green methanol, because it's, as I said, it's not a zero carbon fuel, it's a net zero carbon fuel. That means you should burn also you should burn only those carbon molecules which you have taken out of the system. That means the air in advance. Of course, for the beginning, we may consider also carbon from industry processes. Please not think about coal power plants, but for example, cement industry or other industries where you can't avoid, from today's point of view, the carbon emission. That would be already beneficial for the climate. But at the end, as I said, we need to talk about direct air capturing, which means most probably that those fuels are more expensive than the carbon fuels like ammonia. So from your point of view, you said it, Daniel, for methanol already, but what's from your point of view the advantage of thinking on other carbon fuels?
Okay, so maybe and I start. Yeah, maybe I think that it's good that you raised that point, because we believe e-diesel is really one of the important fuels, because at the end if we have an existing fleet, and I think the renewable rate of in the maritime industry is around 2% per year. So just say how long, when we have, let's say, climate neutral technologies, will it take? So so for maritime industry to really, at the end, it's about to get real CO2 emissions down. We believe diesel as a drop-in fuel for the high-speed engine, it will be really e-diesel. It's really essential that we have that. Otherwise, it will take very long, because just new ships, run on methanol or ammonia will have the benefit, and we need to address the existing fleet. And besides using it in the existing fleet, e-diesel can access the existing infrastructure, has the high energy density. And what we heard from discussion with customers is, especially for when they say, okay, I have ships and they have not that much operating hours. I'm even willing to pay some premium, and I'm not talking on the premium fossil to e-fuel, but maybe the premium to e-methanol to e-diesel, because that makes the total cost of ownership for me right, because it makes no sense to completely install a new engine, new tank system, whatever is needed. So that's also for them really clearly a way to getting the CO2 emission of the fleet down. So we believe that's an important part of the future fuel mix we need.
Yeah, very good point. Thank you, Daniel. Dorte, some additional comments from your end?
Not so much to add. Completely agree that such fuels that are more like the fuels we know will of course be easier to use as drop-in fuels, and I guess here the tricky part is the existing ship, as mentioned, and in principle you have the option to upgrade or retrofit a ship, for example, to use gas or even ammonia. But yeah, that is also why if we look a little bit towards possible or regulation policy drivers, that it should be, you can say, technology neutral, because for some it may make sense to make a retrofit and use a zero carbon fuel, but for others, like Daniel mentioned, it may be make more sense to maybe pay more for the fuel, but keep the existing installations as they are. So yeah, again, a variety of solutions that are not only depending on, you can say, on technology, but also on when, where, and how the ship is actually operating, how long you can say is the remaining lifetime of the ship, and so on.
Yeah, okay, thank you. And you mentioned one word I would like to come back later on also, that's retrofitting, because this is of course a very important question from today's point of view. If you don't want to wait for the technologies to come, but if you need to order a ship today for whatever kind of application, you may prefer to decide on a technology you can use now for the upcoming, I don't know, 10 or 15 years, and to use a retrofitting later on. So maybe you both can also say something about these possibilities from your technical perspective. I would like to come to one question in the chat, which is, from my point of view, a little bit the question at all, considering the IMO discussions, because it's a question if e-methanol or other net zero carbon fuels might be accepted at all, with regard to the climate discussion and regulation. That's of course something we don't know. Again, we are looking into a very foggy crystal ball. However, I would, from today's point of view, I would say it doesn't make any sense not to accept it, because at the end the target is to save the climate and not to push a certain technology. And in that regard, we should consider a life cycle analysis and a complete picture of the system from well to wake, and not only the end of pipe discussion. But of course, we all know at the moment the discussion is very much driven from the end of pipe point of view, which is, by the way, not only a problem for shipping industry but also for other industries. You may imagine or you may consider the aviation, yeah, same problem, but also the car industry, not necessarily talking about private cars, but for heavy-duty trucks, it's of course also a reasonable option to think about not only battery and fuel cell techniques, but also on e-fuels. So I hope a year from today onwards, we may be able to see different answers, but from today's point of view, it's very difficult to answer that one. There's another question. I have no clue to answer it, but I'm pretty sure Daniel and Dorte are in the situation to answer it sufficiently. What is the preferred way to burn either methanol or ammonia with a low pressure port intake or with a direct injection? And you can also please take the chance to say something regarding the retrofitting, not to forget about that topic. Who wants to start? Maybe Dorte again.
Thank you. I must admit that I am not an engine expert. So regarding specific combustion principles, I know at least for the ammonia, that is, you can say, as a dual fuel engine according to the diesel principle. I'm quite certain that is the same for the methanol. That is what we do primarily do with the large two-stroke engines. In case of further technical questions, our technical experts will be happy to deliberate
that's a good
further.
point, Dorte. That's a principal thing for these kind of events. If any of the participants has further detailed questions, please do not hesitate to contact either the panelists here directly or CIMAC in principle. We will share these questions then with our members and come back to you later on. So valid point. And Dorte, regarding retrofitting, because you mentioned the dual fuel engine, that sounds to me that there is also a principal possibility for retrofitting. Is that correct?
That is correct, and that is one of the challenges, you can say, for us as engine developer and technology developer. That is, you can say, the amount of possibilities that we could actually follow, as Daniel also mentioned, the very broad production or product line. We could make retrofits for all, or not all, but in principle it is possible. But it is also a question of, will it be something that will be requested? And there we come back to polishing the crystal ball with regards to how will what would be required from existing ships and so on. So technically possible, yes, to retrofit. Whereas retrofit, depending on, you can say, the extent, is never completely trivial. If you go on board a ship and make a retrofit, it is always, you can say, a specific task to do. So technical possible, but needs to be developed, and maybe in some cases even, you can say, custom fit. So yeah, there are some challenges there.
Okay, thank you. And Daniel, from your point of view?
Yeah, maybe technically speaking, for methanol, so direct injection would be the preferred one, but at the end, it's like Dorte said, it's a bit how you approach it, because the port injection would go more in a retrofit option round, and it's just, okay, how much would you like to have the best solution, the technical sophisticated, or the faster one? And so we will running several concepts on single cylinders right now, so a little bit to wait, but when I have all the results and what we can share with that. Regarding retrofit, I mean, it's coming for Rolls-Royce more from the high-speed engine side. So retrofit is also in that type of engines always a bit challenging, because you have very highly integrated, not much really space left, where you really do a retrofit. We have seen it with LNG, which was, I would say, nearly not possible, and transfer any existing diesel ship to LNG because you just are not able to bring all the LNG systems into a small tugboat or whatever, which is a typical application. So that's just in that type of application difficult. But what we see more and more customers when they ask us for a project, and I think maybe others will see that too, and they say, okay, I have a clear target. I want to become climate neutral by then and then, and the ship will run for that. Let's make a study together and explain us options, how we, in a later stage, can we transfer it to a addition of a fuel cell methanol, and what is the best option. So that's what we see, that a lot of customers want to make at least their ship design future-proof, and so then reserve some space for larger tanker or whatever. So I think that's a part of that stakeholder dialogue we need.
Yeah. Okay. Very good. Thank you. Regarding LNG, what you just mentioned, that's a topic we didn't talk about at all. I mean, of course, it's also possible to switch from the fossil LNG, what you may use today, to a green or e-LNG, synthetic LNG. Of course, it's not LNG then anymore, but you know what I mean, in future, so synthetic methane. A very short answer from both of you, because now we just have a couple of minutes remaining, and I would like to come back to the latest questions from the participants. Daniel, if I may ask you to start.
Yeah, so I mean, clearly we see that LNG is now establishing as a second fuel. It's fossil LNG, like you mentioned it. So also from that perspective, and because LNG in the synthesis step is easier than the liquid ones, is a way we need and should consider to have that as a e-fuel. I mean, clearly in that's, I think that's not even a white elephant anymore. The methane slip needs to be addressed and is addressed. And clearly it's something we need to do as an engine manufacturer, but the most methane slip comes from the distribution chain. And this really needs to be solved, because otherwise the complete greenhouse gas balance is not working. But from our perspective, this is addressed. This is also from EU and other political stakeholders now heavily addressed and probably will be regulated. And if this can be solved, that's really a part of the solution at the end.
Okay, thank you, Daniel. Dorte, any additions, any comments from your end on LNG?
Yeah, not much to add to what Daniel says. The LNG or gas engines are there, so it will also very much depend on, as you say, on the supply side, how much and what will be the cost of such bio LNG, if we call it that.
Okay, and in principle, I mean, depending probably on a certain engine, but in principle, it would be possible in future to switch from or to retrofit an LNG engine to an ammonia engine. Is that true? That's something I read quite some time ago.
Just yes, from a principle perspective. Yeah, it is not a solution that you can come in and buy today, but in principle, yes.
Yeah. Okay. Yeah. Yeah. Then I have two further questions from the chat. The one is something I may answer very briefly, because it's a topic we touched already. The discussed CO2 tax or any kind of CO2 pricing at the end comes, of course, with a matter of the distinction between net carbon fuels and real zero carbon fuels. And from my point of view, I would say, as long as this is not solved or discussed finally at international level, in a sense that the investors know what's coming up, there will be no big production investments on any kind of net zero fuels. But I hope nevertheless that this is a topic we may decide at international level within the upcoming years. Then I have another very specific question explicitly to you, Daniel. Looking at the energy density of methanol, which is the half smaller compared to diesel, what do you think is a useful way to inject the higher required quantity using the diffusive diesel combustion? I'm not sure if you are able to answer that. I wouldn't be able.
That's maybe something where I also need to contact my experts. How they handle that, if they just let's say increase the injection pressure. So, but I wanted to give like German Halbverhalten. So I would really try to take that with me and see if I have really answer for that.
Okay. Yeah, then I think we can come back to that person after the meeting again with a sufficient answer. Yeah, 3 minutes left. I take the chance first of all to thank you both, also for that changed setting of the panel here. I hope it was an interesting discussion for all the participants. I'm pretty sure we will repeat something like that later on this year after our publication of the announced position paper and white papers on that topic. But for the time being, thank you very much again. It was a pleasure to talk to you. And if my colleagues have a slide ready with some advertising for further tech talks, I don't know if we have a fixed date already. If not, it's also fine just to announce it in principle, and you will get the information on our website in time. Yeah, it seems not that there's any slide upcoming. Then once again, thank you very much, Dorte. Thank you very much, Daniel, and also thank you very much to all the participants. I wish you a great summer. Stay healthy and safe without any pandemic impact. And I'm happy to see you again then somewhere in autumn. Thank you very much.
Thank you.
Thank you.
Bye.
Bye.
Bye-bye.